Hello and welcome students to the next session on differential equations, grade 12th. And we'll just continue with the remaining concepts of this chapter. The first one is finding the solution of a differential equation using variables separable method. So in our previous class, we discussed that how we can formulate a differential equation when a general solution is given to us. So in this lesson, just we'll understand the vice versa of this. For example, if a differential equation of first degree and first order is given to us, then we'll see that how by using variable separable method, we can find the solution of that equation of first degree and first order. So first of all, let's understand that what basically a variable separable method is and what are the conditions that in those conditions we can apply this method. So let's take an example. Let's take this differential equation, that is dy upon dx is equals to a function of x comma y. So if somehow we can split this function f of x comma y into two different functions of two separate variables, okay, then only we can apply the variable separable method. So as you can see this flow chart or flow diagram, that if the differential equation dy upon dx is equals to f of x comma y is a function of two variables altogether. So if somehow we can split this function into two different functions, which is h of y and g of x, which are two different functions of two different variables. So if we can split this function, which was initially f of x comma y, so in this case we can apply variable separable method. And if we are not able to split the function into two different variables somehow, then this method will not be applied. Okay, so that type of equations we can solve with different method. So which is beyond the scope of this lesson, that we can discuss later somewhere else. But for this lesson, we'll just focus on if we can split the given function into two different functions of two separate variables, then we can just apply the variable separable method, right? So let's take an example and just check it out, this method. So first of all, the function, or the we can say the differential equation is dy upon dx is equals to a function of f of x comma y. As you can compare that, that is a function of two different variables altogether. So if we can split this function f of x comma y into two different functions of separate variables, then only we'll be able to apply our variable separable method. So let's see if we can do that. So the initial equation is dy upon dx is equals to 1 plus y square upon 1 plus x into xy. So now let's try to split the right hand side into two different functions. So the first function we can write is in terms of x and the other function in terms of y. So the first function that we got is 1 upon 1 plus x into x. And the second function that we got, for example, g of y, that is 1 plus y square upon y. So successfully, we split the function into two different functions of two separate variables, that is g of x and h of y. So it is clear that now we can apply our variable separable method. So what is the first step? To split the function into two different functions of different variables. Now what we can do, we can transpose the function which is in terms of y on the right hand side, and the function which is in terms of x, that will be surely on the right hand side. So and now what you can observe that on the left hand side of the equation we are having a function with y along with dy, and on the right hand side we are having the function which is in terms of x along with dx. Now we'll apply some concepts of integration that you have already learned. So some skills of integration will be tested over here. So what we have to do, the next step is to integrate on both sides. On the left hand side we have to integrate with respect to y, and similarly on the right hand side we have to just integrate with respect to x. So that's easy for you, I think, if you have studied integrals in detail. So what formulas we can apply over here, as you can observe. So integral of y upon 1 plus y square dy is equals to integral of 1 upon x minus 1 upon 1 plus x into dx. So the first formula that we are applying on left hand side is integral of f dash x by f of x, that is into dx is equals to log of fx plus c. Okay. Similarly, on the right hand side, we can apply this formula, that is integral of 1 upon x into dx is equals to log x plus c. So in further simplification, by applying these formulas, you will get this equation. And further, we can use log identities. For example, log m to the power n is n log m. And similarly, we can use various log properties over here. For example, log m minus log n is equals to log m by n, that we are using over here. That is log of cx upon 1 upon x. And on the left hand side also we are using. So Further, after cancelling out log, what we are getting over here, that is 1 plus y squared to the power 1 by 2 is equals to cx upon 1 plus x. So if squatting on both sides, we'll get this equation. This is the final equation that we got. That is 1 plus y square is equals to cx upon 1 plus x whole square. Now what we can do, we can substitute this, we can transpose on the left hand side. So final equation that we are about to get is uh, 1 plus y square into 1 plus x square is equals to cx square. So that is the general solution of this differential equation that we got. So in this way, we have to follow the procedure while solving the differential equation with the help of variable separable method. So the first step is to just separate the variables. Okay, now separate the function into two different functions of two different variables. For example, x and y. For example, as we have shown in the flow diagram. So in that way, first of all, you have to separate the function into two separate functions of different variables. Then further, we can make the variables of, for example, x, okay, on left hand side or right hand side. So you can separate the variables on beyond both the sides of the equal to sign. Then after separating the variables, you have to just integrate that. And after integration of both sides, whatever you are getting the value, after applying some simplifications, you will get the final equation as you can see it out over here. So this was all about the variable separable method. So the first step, as you can see, we have split the function into two. Then we have taken the y variables on the left hand side and x on the right hand side. And then after integrating on both sides with respect to x and y respectively. So this was the flow diagram that we just checked that if the function f of x comma y can be split into two parts, that is h of y and g of x, then we can surely apply the variable separable method. So that's all for this session. We'll just continue with more questions in our upcoming Zoom session. So till then, that's all from my side. And thanks a lot for joining in over here and watching the video class. Assalamu alaikum to all of you.